Okay, so day 4. This is a very important transition point in our learning about electronics. This is today we are going to actually transition from DC circuits to practical AC circuits. We do that by first studying the effect that a capacitor has on being able to separate DC and AC. As we know, DC is stopped by a capacitor, but we will find out that AC is not stopped by a capacitor. And in fact, there are conditions in which your AC signal can actually move right through a capacitor. So it's a good way to separate a circuit that has DC circuitry on one side and enter another circuit that is alternating current source. Okay, so we can separate the two, and that way we can, when we get to more complex circuits and when we get to more of the more modern circuits, we now have a way of having both DC and AC. So we say basically that AC signals can be biased. Okay, it means they can change their mean voltage by adding a DC signal to it. Okay, but if we do that, we also have to protect the DC side to make sure it doesn't get any AC signals into it. We do that by using a capacitor. So today we will learn first what happens if we put a capacitor in a DC circuit. And that will give us an idea of what abilities are with a capacitor, how it charges up and how it discharges down. Okay, and it basically allows then in an AC signal, what happens, it continuously charges and discharges. So in the charging and the discharging, what we're doing is building up an energy into the capacitor and then relieving that energy. So we increase the energy, we store some energy, and then we release it. Store and release. And that's what happens when an AC signal goes through a capacitor. Okay, so let's start the lecture.